Good morning, class. In the previous video we learned about the wind, then we learned about the weather instruments, namely the thermometer. We talked about the Celsius or centigrade thermometer, invented in 1742. Then the Fahrenheit scale, invented in 1724. Then we learned about the Stevenson screen and how it is useful. So today we are going to learn about the rain gauge. Underline, rain gauge is an instrument made up either of metal or glass or even with plastic and used to measure rainfall. As the name suggests, gauge is to measure. Now, it consists of a large funnel fitted into a metallic glass vessel which is placed below the funnel. The mouth of the metal funnel is about 15 to 20 centimeter in diameter. The water cannot evaporate from this vessel as the hole of the vessel is small. When the water has been collected for a certain period, it is measured in a graduated glass vessel. Certain period, I am not talking about, it can be certain period over a larger length of time, because then they have to measure the amount of rainfall received within maybe a few hours or so on. Now, when the water has been collected for a certain period, it is measured in a graduated glass vessel. It is important to keep the rain gauge in the open, far away from the buildings and trees. It is placed about 30 to 35 centimeter above the ground so that exact amount of rainfall can be collected for the accurate measurement. A quick look at the apparatus. See, this glass funnel over there, and the water is collecting into a small tube over there which will be marked. You cannot see the markings in the diagram, but it is marked to measure the amount of rainfall. Now let us learn about barometer. Underline please. Barometer is an instrument to measure the atmospheric pressure. It was invented by Evangelista Torricelli in 1643. He used mercury in a vacuum tube to measure the air pressure. So again, the use of mercury, which we saw earlier in the thermometers. When air pressure increases, the mercury moves up in the tube and we can take the reading from the scale marked on it. When the pressure decreases, the level of mercury also decreases in the tube. Since then, many changes have occurred and now digital barometers are available which just display the actual reading. So, like the digital thermometers, we have digital barometers also. So, a quick look at the barometer over here, the diagram given in your book. Now, hygrometer. Hygrometer, underline, is an instrument to measure humidity in the air. Inside the traditional hygrometers, there are two bulbs, one wet and one dry. They are the special thermometers to record the temperature with the relative humidity of the air of a particular area. So, can you see over there the hygrometer? You cannot see the bulbs and all very clearly over there. So, we'll have to get hold of something in physical. We'll see whether it is there in school or not, and then I'll show it to you when the school reopens. Now, at present, the digital hydrometers are used to record the relative humidity and temperature. So, another technology has advanced, so we now have digital hygrometers also. Now, anemometer and wind vane. Underline, an anemometer is a device used to measure wind speed. It is made up of several cups, usually of metal, attached to a vertical shaft. Can you see over there? The wind causes the cups to move, which in turn move the shaft. This way, the wind speed is calculated. Now, wind vane is for finding the wind direction. It is one of the earliest weather instruments used in human history. It has been known to mankind, or mankind has invented it from ancient periods. It has two parts, a pointer and a fixed direction marker pointing towards the north, south, east and west. The shape of the pointer is made in such a way that the mass of each end is even, but each end has different volumes. When the wind pushes the thick end of the pointer, it swings and the arrow points towards the direction in which the wind is blowing. You may see a wind vane on many buildings. Arrow and rooster are some of the popular designs to be found on the pointer end of the vane. So this rooster which you see over here, this is called a cock, or is called a rooster. Okay, so it is a very popular design and has been known, man has had it since ancient times. Now let us see what are isoheights. Underline, iso means equal and height means rain. Therefore, isoheight is a line on a map which connects the places having equal amount of rainfall. Look at the diagram given over there, say children. Okay, so the lines show, wherever the lines are going, these places are places which have equal amount of rainfall during a certain period of time. Now, on the weather map, to show the typical similarity or dissimilarity of rainfall of different places, or to compare the amount of rainfall of different places, isoheights are useful. So it can be asked as isoheights are useful, give reason. So what will be the answer? Please mark it down. On the weather map, to show the typical similarity or dissimilarity of rainfall of different places, or to compare the amount of rainfall of different places, isoheights are useful. Now isotherms. See children, iso means, over here also iso means equal, and therm means thermos or heat, thermometer, remember. Now therefore, isotherm is a line on a map connecting the places having the same temperature at a given time, or their average temperatures over a period of time. So let's quickly take a look at the map given over here. So degree centigrade, okay, 15 degree here and then 15 degree here. So these places, they have the same temperature over a certain period of time. Now again, this can be marked as give reason. To show the same temperature of different places on a given point of time, isotherms are a useful way to show that on a weather map. So again, the statement can be isotherms are useful, give reason. So you will just please mark it down, underline it, to show the same temperature of different places on a given point of time. Now key terms are very important, children. Please learn them by heart. They can be asked as definitions. Drizzle, cumulonimbus, hailstone, horizontal movement and pressure gradient. All these I have already discussed with you in detail. Now this chapter is over. Let's relook. This is also important. You need to learn things from here where they are given in a much simpler explanation. I want you to go read the chapter again, and if there is any confusion or any topic which you have not understood, either rewind the video or note it down, and we will discuss it when the school reopens. Now let us quickly go through the objective type questions over there. See, you can do this work yourself when you are reading the chapter. You can underline the find out the answers on your own. Now, right, nimbus clouds do not bring rain. It is a false statement. They do bring rain. Relative humidity is expressed in percentage. 2. Fahrenheit cannot be converted into Celsius. This is also false. It can be. Air does not have weight. Air does have weight. Now dew falls from the sky. Now children, I think I have already uploaded the answers to this. So B1, okay, the give reason. So dew does not fall from the sky as it forms water droplets. What is a dew? It is a water droplet that forms on surface when the day is very warm and clear, and it is followed by a cool clear night. Then you find dew in the morning. So please go through the chapter once again, and we'll take up the next chapter in the next class. Study well, stay safe and stay healthy. Thank you.